Hello students, today we are going to see about microprocessors and interfacing subject in NPTEL, that is the week 1 assignment in the topic 8086 architecture. So the first question is the clock frequency of standard 8086 microprocessor is. So the clock is one which is used for internal timing operation of 8086 and specifically it is 5 megahertz in 8086. So the option is first option, which is 5 megahertz. The length of instruction queue in 8086 is. So in 8086 we have two units, namely execution unit and bus interface unit. In bus interface unit we have instruction queue which can fetch 6 bytes of instruction. So the option is second option, which is 6 bytes. Which of the following 8086 register is used to test the conditions? So actually we have some set of instruction in 8086, namely arithmetic instruction, data transfer, logical instruction, control transfer instruction. So in control transfer instruction we need to test some conditions. Only if that condition is satisfied, the 8086 will be going to some other location, execute the subroutine over there. If the condition is not satisfied, it will execute the next set of instruction. So for that we have some condition instructions like jump on carry, jump on no carry, jump on overflow. So where these condition flags exist, so it is in the flag register. So the flag register is having the 9 active flags. In that the status flag is itself 5, that is sign flag, zero flag, auxiliary carry, parity and carry flag. So using these you can check the condition. If the condition is satisfied, you can go to the particular location. If it is not, you can execute the next set of instruction. So the option is last option, that is your flag register. The range of signed 2's complement number that can be stored in 8-bit register. For example, if it is not signed, then we can say that 2 power 8 is 256. So the value ranges from 0 to 255. But here they have given it is signed. So it will take negative numbers also, positive numbers also. So for the negative numbers and positive numbers, to properly split, we can divide that into 128 and 128. So 256 is divided into 128 and 128. So for positive side we have 0 to 127. For negative side we have minus 1 to minus 128. So we can leave this in between. So the range is from minus 128 to plus 127. So that is the range of the signed 2's complement number, since they have given 8-bit register. So we have to take 2 power 8, which is nothing but 256. So divide that by 2, so 128. So positive side 0 to 127, negative side minus 128 to minus 1. Next question, if the 20-bit physical address is 56200 and the content of code segment register is 5500, then the content of instruction pointer in 8086 would be. So actually we have the formula called physical address. Physical address is given by segment register into 10. So here segment register is code segment register. So code segment register into 10 plus your offset. Offset is given by instruction pointer here. So we have in the left hand side physical address is 56200 and segment register value is 5500 into 10 plus IP. So IP can be obtained by subtracting this value from this. So we have 56200 minus, so multiply this value, we will get 55000. So subtract, so 0 0, here we have 2, 6 minus 5 is 1. So this is the value of IP. So the option is first option, 1200 H. If the reset input of 8086 is set to logic 1, the content of code register would be. So always the content of code register would be FFFFH. This is the default value. So the code segment register value will be FFFFH, and totally the physical address whenever we reset it is given by FFFF0H. So that both you have to remember. So that is the default value whenever the reset pin is pressed. In order to operate 8086 in single step mode, which of the following flag need to be set? So we have control flags like trap flag, overflow flag, and interrupt enable flag in 8086. So specifically we have trap flag. So whenever this flag is set to 1, then automatically the 8086 will enter into the single step mode. Okay, so in the flag register we need to set trap flag, which is equal to 1. Only then 8086 will enter into single step mode. Single step mode in the sense 8086 will execute the instruction one by one. After executing one instruction, it gives the result and status of all the flags available, and then only it will go to next instruction. So this is useful when we are writing the code first, so that wherever we have error we can debug it easily. If the starting address of 64 KB code is 0FBC0, the ending address would be, so actually 64 KB we can give the range as 000002 to FFFFF. So if it is so, how we can add? This is the starting address they have given. So in order to obtain the ending address, we can add FFFF with this value. So F plus 0 is F, and F plus C is nothing but 1B. So we have B here and 1 carry, and again B plus 1 is C. C plus F is 1B, so B below and 1 carry. And 1 plus F is nothing but 1F. So here 1 carry is 1. So 1 plus 0 is nothing but 1. So we have the last option 1FBBFH. So 64 KB in the sense always the ending address we have to, in order to get the ending address we have to add FFFF with the starting address. Which of the following 8086 register is used to write subroutines? Actually, subroutine in the sense 8086 will execute one code, and if it has to move to another subroutine, it has to store some value in stack. So it requires the stack pointer. So in order to point out the stack, it requires the stack pointer. The process of overlapping the fetch and execute cycle of 8086 is called. Actually, we have two units, bus interface unit and execution unit. Bus interface unit is used for fetching. Parallelly, execution unit will do the execution. So this process is nothing but pipelining. So with this, the week 1 assignment of microprocessor and interfacing is over. Thank you. Thanks for watching.